So this is 2.3b, college algebra. We're ready for example 4. And so let's go ahead and write that out. Let's put everything in the correct format. Okay, one of the things that you have to understand as far as completing the square is that you can never have a number right here. In the last one we did, there was not a number there. It was x squared minus 6x minus 10. But in this one we have a 2, so we have to get rid of that 2, and the way we get rid of that 2 is we divide every term here by that 2. So that's over 2, that's over 2, that's over 2, and that's over 2. So that gives me x squared minus 3 halves x minus 1 half equals 0. Okay, so let's move the 1 half over. Leave that space there. Alright, so what goes there? Well, we said that it's half of this squared. Half of a fraction means you double the denominator. I don't care what fraction you have. If you have 2/5, to get half of it, it's 2/10. You double the denominator. 3 halves, to get half of that, you double the denominator. Okay? 18/64, to get half of that, 18 over 128. Okay? That's how you take half of any fraction, is you double the denominator. That's all you have to do. So, this here, 3 halves, if we double the denominator, will be 3/4. Okay, let's put that over here. And then I have to square it, so that gives me 9 over 16. So what I'm doing is I'm adding 9 over 16, and you will always, always, always add here. There will always be a plus sign because you're squaring a number. And whenever you multiply a number by itself, it's positive. So because we added 9/16 there, we have to add it to the other side. And we do x, this sign here goes here. Square root of that is 3/4 squared equals 1 half plus 9/16, which is going to be 17/16, if I remember right. Okay, now we take the square root of both sides, and we have x minus 3/4 equals plus or minus 17 over 16. Oops, that's under a square root sign. Okay, so we get x equals 3/4 plus or minus the square root of 17. Okay, square root of 16 is 4. Okay, and that gives me 3 plus square root of 17 over 4, and 3 minus the square root of 17 over 4. Those are my two answers taken from that right there. Any problem with that? All right. So, middle of page 205, down toward the bottom, to solve a quadratic equation by completing the square. It gives you some steps in order to do that. The first step is to isolate the terms with variables on one side of the equation and arrange them in descending order, which basically means taking this equation here, getting the radicals by themselves, or the variables by themselves, and move the 1 over, so the number is over there by itself. So the terms of variables are on one side, and they're in descending order, 2 and then 1 on the exponent. Divide the coefficient if necessary. Divide each term by that coefficient, and take half of the coefficient of the first degree term. This is a first degree term because the exponent is a 1 here. Take half of that and square it, and add that here and add that over here, and then continue on. So follow those steps. Might help to write them down, because sometimes completing the square can be a lot of steps. You might know how to do it, but you might skip a step here and there or get confused with what to do in certain places because you forget a step. Alright, so because completing the square works for any stinking equation, we're going to come up with a formula, and the whole page 206 pretty much is the way to come up with the formula. I am not going to go over that. When I had you for Algebra 2, we probably went over how you get this equation. but that's the equation. And that a, b, and c is basically from this general form of the equation. We don't even care about the x, we just care about the a, b, and the c. Alright, so if we have an equation like 3x squared plus 2x equals 7, we're going to write it as 3x squared, whoops, that's not a squared, plus 2x minus 7 equals 0. So there's my a, there's my b, there's my c, negative 7. So looking at this formula right here, let's go ahead and write it. X equals b is 2, so negative 2, plus or minus the square root of b squared minus 4 times a times c, negative 7, all over 2 times a, 3. Okay, so we get x equals negative 2. We're going to do what's in the square root sign first. 4, 12, 84, is that right? And that's going to be over 6, so x equals negative 2 plus or minus the square root of 88 over 6. Okay, and 88 can be broken down. In fact, I'm just going to erase that and break it down into 4 times 22, and then I can take that 4 out. Oops, not take the 4 out, I take the square root of the 4. Okay. Okay, there's a couple ways to reduce this whole thing here, so I'm just going to do it the way I normally do it, just because it seems to be. I'm going to split this up, because you have this plus sign, plus or minus sign. This is over 6, and this is over 6. So this becomes negative 1/3. This becomes 1/3. So then, whoops, x equals negative 1 plus or minus the square root of 22 all over 3. Okay, so we get two answers. Negative 1 plus square root of 22 over 3, negative 1 minus the square root of 22 over 3. And if you use your calculator, you'll get a number somewhat close to 2. Alright, so let's do example 6 and continue on with these quadratic equations. I don't think these are going to cause you any trouble, but you know, we do get to some different ones because this one's going to have an imaginary number in it, and that's why I want to do this one. Alright, so negative b. So x equals negative b, negative 5 plus or minus the square root of b squared minus 4 times a times c. I don't suggest you doing this in your head. 2 times a. So x equals negative 5 plus or minus the square root 25 minus 32 over 2. So see what we've got? We're going to have a negative number there. So that's going to give us a complex number. Okay, and then I'm just going to change this from a negative 7 to a square root of 7i. Okay, so we get for an answer, if we put it in the right form, and negative 5 halves minus square root of 7i over 2. So we get those two answers, which means this graph does not cross the x-axis, but those are still two answers that we get. All right, that brings me to something called the discriminant. And again, we did this in Algebra 2. We're going to do it again because the discriminant gives me a lot of information, or a bit of information anyway. So when we have the quadratic formula, I had to memorize this back in the 70s, and I still remember it. And I guess I remember it because I teach it all the time. All right, this group of letters and numbers in here is the discriminant. Discriminant is b squared minus 4ac. So if you find the discriminant first, that will give you some information about the problem that you're doing. So, for instance, let's say that we plug some numbers in here, in this part right here, and let's say that we get a 0. Let's say that the number, that when we put the numbers in here, we get basically under that square root sign, 0. All right? When we get 0, that means this plus or minus goes away. So let's say we get 3 plus or minus the square root of 0 over 6. That means this goes away. There's no plus 0 or minus 0. Okay, so how many answers do we get? We get one answer. Okay, so when that discriminant is 0, we get one. We'll have one real number answer. All right, let's say that that number in here, this number we get is greater than 0. So let's say we get 3 plus or minus the square root of 5 over 2. That means we get two answers. We get 3 plus square root of 5, 3 minus the square root of 5. So we get two real number answers when that b squared minus 4ac is greater than 0. Now what happens if this number is less than 0? Well, that means it would be something like this. Tells me I get two imaginary number solutions. I get a 3 plus the square root of negative 7 and a 3 minus the square root of negative 7. So I get two imaginary solutions. Okay? Okay. I'm going to stop here and continue on with 2.3c.